Let's talk more about inverse functions, specifically their domain and range. So remember with inverse functions, they reverse the process. So with an original function, you take x values, plug them in your function, and they spit out y values. With inverse, now we're taking those y values and we're mapping them back to those original input values. So the domain values now of the original function become the output values or the range values of the inverse function. Similarly, now the range of our original function becomes our input values of our inverse since we're reversing the process. So those are now our domain values. We can use this to verify inverse functions. So what f does, f inverse undoes, and vice versa. Therefore, if f inverse of f of x equals x, where x is in the domain of f, and f of f inverse is always going to also equal x, where x is in the domain. So we can actually use this fact to verify if two functions are inverses of each other. So to verify that, what you would do is you would compose f inverse with f, and then you would also compose f with f inverse and ensure that you're getting x out both times. Because again, if you think about this, if I'm going into my function and I'm inputting in an x, I get out a y, and now I take that y value and I'm plugging that into my inverse function, it better map that back to that specific x value since they're just undoing each other basically. Verifying inverse functions. Verify that the inverse function found for finding the equation of an inverse function example 2 was in fact the inverse function of g of x equals x cubed plus 2. Okay, so we found that the inverse function was the cube root of x minus 2. So in order to verify that these are inverses, we need to check and make sure that g inverse of g of x is x, and we need to also check to make sure that g of g inverse of x is also x. If that happens and both of those compositions output x, then we know and we can verify that these are inverses. Okay, so let's do it. So we'll do g inverse of g of x first. Okay, so g of x is x cubed plus 2, so that's what I will be inputting into my g inverse function. So now you go to g inverse, and where you see an x, you'll replace it with x cubed plus 2. So this gives us the cube root of x cubed plus 2 minus 2, which is the cube root of x cubed, which is just x. Sweet, so that checks out. Now let's try the opposite. See what g of g inverse gives us. Because you can't just check one, you have to check both directions. So that means you take your function g and we're going to input what g inverse is, which is the cube root of x minus 2. Go to g, anywhere you see an x, you're going to replace it with that. So we get the cube root of x minus 2 quantity cubed plus 2, which is x minus 2 plus 2, which is x. So that also checks out. So because both of those checked out, we can verify and say that this is definitely the inverse function. Let's verify another inverse function. The function f defined by f of x equals 2x over x minus 1 is 1 to 1. Find the inverse function. Confirm that the inverse function you found is correct by showing that f inverse of f of x equals x, and f of f inverse of x also equals x. Okay, so let's first find the inverse function. Remember to do that, you switch the x and y values. We'll have x equals 2y over y minus 1. And now we need to solve for y. First thing that I'm going to do is multiply both sides by y minus 1. So I can get rid of having a fraction. So that leaves me with xy minus x on the left equals 2y. Now I see here that I have two different terms that have y values in them. So what we're going to do is we're going to get all of the y terms on one side. So we'll move this term over. That leaves me with negative x equals 2y minus xy. Now, since I've gotten all of the y values on one side, I can actually factor y out. So when I factor a y out, I'm left with y times 2 minus x equals negative x. The reason I wanted to factor that y out is now I can actually get that y by itself. Oops. By dividing both sides by 2 minus x. And I'm left with y equals negative x over 2 minus x. I can write this with function notation as f inverse of x equals negative x over 2 minus x. Okay, so again, this ended up getting a little bit trickier because we had multiple terms that had y values in them, and when that happens, just get all of the terms onto one side and then factor that y out. Okay, so now let's make sure I actually did this right by verifying. Okay, we'll do the first one. So f inverse of f of x. When I plug in or substitute in f of x, so f of x was 2x over x minus 1. Go to my f inverse, anywhere I've seen x, I'm going to be substituting in 2x over x minus 1. So that gives me negative 2x over x minus 1 all over 2 minus 2x over x minus 1. So here I have that complex fraction that we dealt with before. In order to get rid of it, multiply both the numerator and denominator by that common denominator, which is x minus 1. So that leaves me with a negative 2x in the numerator. And then the denominator, make sure you multiply this to both terms. So I'm going to get 2 times x minus 1 minus, when I multiply that x minus 1 to this part, those will cancel and I'm just left with 2x. So now when I simplify this, I'm left with negative 2x over 2x minus 2 minus 2x, which gives me negative 2x all over negative 2, which is x. So that checks out. Now we'll do the other way. F of f inverse of x. So that's f of negative x over 2 minus x, which gives us 2 times negative x over 2 minus x all over negative x over 2 minus x minus 1. Multiply both sides by that 2 minus x. When I do that, that cancels with that, so I'm left with negative 2x in the numerator. When I multiply that over here, it cancels out that denominator, so I'm left with negative x. When I multiply it here, I'm left with negative 1 times 2 minus x. So that gives me negative 2x over negative x minus 2 plus x, which is negative 2x over negative 2, which is also just x. So that checks. The function f defined by f of x equals 2x minus 1 over x plus 1 is 1 to 1. Find its inverse and state the domain and range of both f and its inverse function. Okay. So to find its inverse, you switch x and y. So we get x equals 2y minus 1 over y plus 1. I'm going to multiply both sides by y plus 1 to clear that fraction. And we're left with xy plus x equals 2y minus 1. Now, in this case, again, we have two different terms that have y values. So let's get all of the y value terms on one side and anything that doesn't have a y on the other. So I'm going to move this term over so that I can have all the y's on the right. And I'll move the minus 1 over to the left-hand side so everything that doesn't have a y is moved on the left. So on the left-hand side of the equal sign, I'm left with x plus 1. And on the right-hand side, I'm left with 2y minus xy. Now that I have all the y's together, I can factor y out. And that leaves me with 2 minus x. So y times 2 minus x, and I have x plus 1 on the left. Now that I have the y factored out, I can actually divide both sides by that 2 minus x. And that leaves me with y equals x plus 1 over 2 minus x. Now if I write that using inverse function notation, f inverse of x equals x plus 1 over 2 minus x. I'll leave the verifying of that up to you. So remember to verify, you need to show that f inverse of f of x equals x and f of f inverse of x equals x. This is great practice to make sure that you're good at dealing with complex fractions, because these will definitely give you complex fractions when you compose these two together. Okay, now it asks us to state the domain and range of both f and its inverse. Looking at, so let's draw a little. So let's deal with f, domain, which I'll actually do this, domain, range. We've got f and f inverse. Okay. We can look at these and easily see what the domain is. So here you can tell the domain of f is going to be all values of x such that x cannot equal -1. And for the domain of f inverse, we can see that it's going to be all values of x such that x cannot equal 2, because those are the values that will make that denominator equal 0. Now, I don't know about you, but I can't look at these equations and formulas to figure out what the range of them are. But luckily, because these are inverse functions, we know that the domain of f is the range of f inverse. And we know vice versa that the range of f inverse, or domain of f inverse, is the range of f, since these are reverse processes of each other. So when you're asked to find the domain and range of a function, and it's harder for you to be able to distinguish what that range is without graphing it, you can find the inverse, find its domain, and that domain is going to be the range of the original function. For more examples on finding more complicated inverse functions, click here, and this will help you with these types of functions where you're going to have that y value in two different terms. So if you're wanting to see more of that, go ahead and click that example.